We are going to talk about what we really like to do. We like to build our programmatic solutions easily, not thinking of some problems we thought uh, been solved for a long time ago. And one of the bricks in our basement is, of course, maybe the basement itself is the platform that runs our jars, our code. It's OpenJDK, and we would like to use it as a reliable tool. So what is it about? Why I'm talking about it? I work at BellSoft, and we do a lot of great things, including binary distribution of OpenJDK called Liberica JDK. And we not just release it, but we develop the OpenJDK itself. Uh, the team actively contributes, and you see two LTS pictures for two LTS releases here for contributions from different companies. And it's good to be in that company of companies and in the company itself. Our installation base is really wide. So the work that we do, we support JetBrains runtime that powers JetBrains IDEs for different languages. Liberica itself, as I said, the binary distribution, and it's among top 8, if I remember correctly, uh, installed distributions according to New Relic data. Liberica also powers by default Spring Boot containers and VMware Tanzu as a runtime, so it is a large install base also. And there is a new player here, Liberica Native Image Kit, a tool for creating native images, which we also offer in our toolset. And of course, then we release all that binaries that are not just 2 binaries or 4 binaries. No, it's almost 300 binaries in each release. We don't have a pattern of continuous delivery, so it's not daily, more like once in a week, and definitely every quarter, because Java update is released by all distribution vendors quarterly that sit on top of OpenJDK. And now we have 3 long-term supported releases. For the next release, that will be 3 LTS releases and 1 major release, and actually 2 old releases also. 6 and 7, not listed here. Each JDK release passes very sophisticated testing. There's a lot of tests. And that's released not for a single platform, OS and CPU type, but for more than 12 platforms. So it is a pain. We have very different machines, devices, and not sometimes a kind of server, but maybe some board, some cloud machines, all managed to run necessary builds and tests. And then we deploy final artifacts, some to public, some to private space. And we also offer APIs to work with metadata and binaries, and we will talk about that APIs today. Of course, modern Java distribution must provide container images, and we produce them for sure, and some other channels that also be covered in this presentation. So what's the goal? Then we take Java platform. We would like to take it easily, to be ready for usage, to provide diagnostic tools, to conform the specification. Well, we would like to make it a very simple step in the entire complex CI/CD task set. Well, yes, we need JDK or just the runtime or maybe stripped runtime if we use JLink. And often they have very different environments than they operate. That can be a combined set of different clouds, of some desktops, maybe with some GUI applications, people who interact and operate that runtimes, they're also different. That may be a developer, an end user, maybe a tester, maybe that may be a robot. And yes, of course, then classical release process goes. We do something in development environment and staging. We build some artifacts for testing, and then they go to production. Well, why would we change something? Because we have to. We have vulnerabilities discovered that may be exploited, and they are fixed in new builds. We have bugs found, and some releases just go end of life and become outdated. No one can, I believe, hire a new programmer that will write Java 1.4 code looking at all the new features of Java 17, right? So we need a new release for that. And if I talk about security, remember that CVEs are constantly being found and being fixed. Luckily, stability of Java releases improved dramatically over the last years. You see that there used to be a lot of vulnerabilities with high severities, but it became less now. And also one of the important things that make us to change and update our JDKs is performance. Performance for new updates, performance for new releases. For example, in one of my talks, I have an example of a microservice that just starts and does nothing. And if we simply upgrade the JDK that runs it within the same major release, we have very impressive savings for runtime footprint this application. Another interesting topic is which distributions are free and which are not, and what is the release cadence, and what are the support dates, different releases. You have to know it. You have to think of what will happen with your production in 5 years, maybe at least within 2 years, right? For now, will you migrate? Will you be able to migrate? So yes, we still have 8 as an active LTS release. Past releases, past feature releases that they're not LTS are in the past now, right? And now we have new license for Oracle Java starting from release 17. It has some interesting sides. I won't discuss that in much detail, but you have to know that there's still a license, and there are some limitations, there are some promises. And of course, Oracle OpenJDK is still there, and it's still updated every 6 months to a new major release, right? So how would we update stuff? Well, we need to perform certain actions to find out what software is available for us, to install it, maybe to change the installation, maybe to install multiple versions, and finally to remove the versions we don't need. It's that easy, right? Let's take the source. If we need some critical security patches, let's patch it. Maybe then if we need to apply that to several machines, we can create a binary package. It's OpenJDK, it's open source. Well, unfortunately, it's not that easy because you need to test things and you need to know what version are you running and how it works. Sometimes that approach works, but I wouldn't recommend it. Well, more another approach is to install a package, right? Let's consider some Linux environments with some package manager, then we can install OpenJDK and it will be fine, right? How often it will be upgraded? Who knows, right? It depends on the distribution. It depends on what's being installed there. And of course, in any case, what happens is that first, OpenJDK is tagged with a certain version that has a known set of security patches and other functionality, functional changes, and that security patches are prepared involving the OpenJDK security vulnerability group. And after those patches being discussed in that closed circle privately, they go in public in the same time. And then all different distributions go to public websites or appear in Linux distribution repositories. Sometimes builds may be prepared not entirely properly. In such case, the same release may be re-released with a new build number, and you see it often. So finally, we need to download something. The easiest way is to go to some website. Well, I search download Java, probably I go to Oracle site, but sometimes to a site like our BellSoft site. And then I need to choose my platform, choose the type of packaging or installer I want to run, download it, and that's it. Well, even this step may be complex because there are different flavors of the same JDK. Like, for example, we offer full flavor that includes JavaFX, includes standard one, and also the light one that's still fully compatible with the specification, but has some things stripped off to be more lightweight, be better suitable for containers, for example. And then they run the installer, well, like this. By the way, please note that there is a verified publisher. It's important to have the unattended mode, and we'll see it later why it's important. In some systems, installer may look slightly different, right? But still, it's good to have the notarized installer binary, notarized JDK binaries, right? To have no warnings or non-functional executables in your installation. To be able to uninstall it using the same installer, because sometimes it's more simple than using some command line tricks to deal with installed software. Okay, the real installers to me looks like this. We have either a Linux package or just a tarball zip or targz. Then we uncompress it and use the installation of the JDK. Still, we have to download that from somewhere. Well, containers, I mentioned them earlier. Containers may be based on different OS environments, and it makes sense to look what's inside. And sometimes we need different buildings, different constructions of container images in different situations. Well, again, the simple way. Let's take something. Probably it takes too long to be downloaded to new hosts. Why? Because it's humongous. There's some big JDK part inside, big OS part, and that's for 17. And for older releases, it's more than 500 megabytes. Too big from my perspective. Well, you may have another opinion. But consider this. We can build our own container that runs some simple applications requiring only Java-based module, and it will be 10 times smaller. Well, that makes some sense. And we can have a fully functional JDK less than 100 megabytes. The number here was rounded. It's actually less than 100 megabytes. That's achieved for a very special Linux distribution called Alpine Linux. It has a different C library, which is small on disk. But for other base distributions, it also can be achieved. I mean, smaller size over the wire and on disk. How to choose which base image you should take? Well, first of all, you have to decide, do you need a native image or not? If native images, you have smaller overall size of the container. We'll see how smaller it is. But it will be almost monolith. So it's not a layered image. So if you deploy and provision a new host, then you will have more heavy trade-offs. Well, in classical case, you can get a very tiny top layer with your business logic. And if it's frequently updated, it makes more sense. And then you have to choose which environment do you prefer. Do you really need the glibc C library, or you can go with another implementation? Do you need a specific package manager? And then, well, you have this helper diagram. Please use it. Another approach is to use Liberica built into Spring Boot, for example. If you take some sample and create a container from it using modern version of Spring Boot and using Spring Native, you see that approximate size of the container will already be small enough. And in case of container div JVM, it will be a layered image where Spring libraries also split it into layers. And in the case of native image, it will be just small, much smaller. Be careful then you select the base image for your container, because sometimes you won't have features that you expect to be there, or you will have a very outdated Java. Well, if you don't follow the versions of JDK, you may easily get a container that will be 1 year outdated in terms of security. That's incredible to me, but still it may happen very easily. Another situation, well, sometimes you install OpenJDK package from your distro, but it just doesn't work as expected. For example, you won't get all the links for all the standard tools, all the other assets set up for you. Well, that's unexpected. Or you try to use that standard, one of the standard tools, and it just doesn't work. Like in this example, you try to use jcommand and to get the uptime, the command, and you just get thread dump instead of it. But by using just another base image, you get everything working. All right, what's about APIs? Well, they are interesting. The process of API design is a big fun. We use our own technologies in this area. We have a REST service that provides Discovery API for Liberica and Liberica Native Image Kit. It opens open API specification. There are detailed examples. Please check that information. Why do they need it? Well, sometimes, for example, we wish to have a Slack bot that will say, hey, new Java release is there, or, well, your production is 2 security updates outdated, or something like that. That can be automated by consuming metadata from somewhere in a different ways, in different languages, and even in shell scripts. Like our examples use simple curl and invoke a REST method for Windows. We designed such a good API that we still keep the version 1. I really like that fact. We provide information about architectures we support, operating systems, and of course, finally, you get download link and a checksum. Besides of the API itself, that download links are actually, well, persistent. So they were not changed for ages, so since the start of the API. And by the way, Oracle just did that part. They introduced constant download URLs for Oracle JDK. That also requires no registration to proceed. So how do we use that API? First, we can use the simple text format. You see a very long request on the top of the slide. And in the end, they get a response, the download URL. So long request, but it's rather simple if you look at any part of it. And if we don't want text format, we just remove that part that instructs the API to respond to text. And we got a JSON. And it is the JSON, the full metadata. You have all the information about size without downloading it. Of course, the checksum, metadata about operating system and supported CPU architecture. So all that. You have options how to invoke that API. You may make multiple calls trying to get tiny pieces of data. You can make one big call and then work that information offline. It's allowed to do both, whatever you like. Just please be wise. Of course, if you request the entire metadata for all the releases for all the platforms, well, the response may be not so fast as in the case where you just ask for a single download link. One of examples for the API is the entire role for installing JDK for Ansible. And what's cool, it's cross-platform. So it works on Windows, if I remember correctly, on 2 different ones, and on Linux as too. So you can go and study good example of working API usage. So other nice things, what we are talking about in all this talk is those are tasks for package managers, right? Installing, updating, pulling dependencies. So of course, it's good to support package managers, and it's highly recommended to use package managers and repositories to install JDK and to update it in an automated manner, or leave the specific version. Again, it's possible with any normal package manager. So we support some popular ones. We have our own repositories that, not surprisingly, are located in something like yum.bellsw.com, etc. And workflow is the same. You go, install the repository, install our key, and then you can scan the repository to find the version that you need, and you can install it or change the installation using your package manager. And our images that you can find in marketplaces for Azure and for Yandex Cloud are based on the same approach. They just used pre-installed repository and Liberica inside. So you can get it and you can update it instantly. Then you get such an image. Another cool thing for us, then we use GitHub, and OpenJDK uses GitHub and uses some cool things there. But for developers, it's convenient to utilize GitHub Actions. And there's a pull request that brings Liberica JDK into setup Java GitHub action. So getting back to package managers, not all systems has, well, out-of-the-box package managers as convenient as Linux has. Well, still you can install really easily some alternative implementations like SDKman on macOS and also on Linux, by the way. So you can unify your Mac and Linux scripts, for example, Homebrew. And then the workflow is the same as on Linux, right? You search, locate, and then install some packages with JDK. We have detailed description, but don't forget about Windows. For Windows, it's even more interesting, but it's now became much easier with Winget. And the funny fact that the only JDK 17 in Winget currently is Liberica. Please try it. And that package managers, by the way, invoke MSI installers. So it's very important to have silent mode there, right? Because we then perform normal OS installer setup. Well, that's not bad. After that, if we have a lot of Windows machines, for examples, it's really hard to manage all the JDK installations. And then especially it is critical then you have licensing issues. So we created a solution that is built from an agent and some administration interface to detect all running JDK types in your fleet where you installed that solution, and to perform tasks like upgrade of certain machines or groups of machines, rolling out new versions, or even auto update of JDKs, which is a very popular scenario. And some dashboards that provide DevOps or managers information about what are security risks, what are licensing issues currently in the network, and the command interface to fix all the potential problems and to keep all your fleet up to date. The selected flavors of JDKs for all the managed systems. So I hope that I covered many typical tasks And we would like, in the tools that we provide, to help DevOps to perform the tasks with a blink of an eye. Thank you.